Magandang araw, maupay na adlaw, buenas tardes, and good day. Today, we will be talking about predicting future outcomes with the use of polynomial functions and derivation. Without further ado, grab your graphing calculator and let's get calculating. Population is a common example where we can apply the rate of change, or the derivative of a function from a given situation. To further understand this topic, let's analyze it with a problem. Silver National High School started its senior high school with a population of 1,200 grade 11 learners on the school year 2016-2017. The first problem is that it was predicted that the population Y would increase to a model of the function of x, or f of x, is equal to 60x plus 1,200. What is the expected rate of change of the population each year? Using our graphing calculator, we can solve for the rate of change much easier by following these steps. First, we will press the Math button, then press 8 to access and derive template. After that, you will be redirected to where you can substitute the given function. So d over d and our variable x, then input our function 60x plus 1,200 inside the parentheses, having the value of x is equal to x. In this case, the derivative of our function 60x plus 1,200 is equal to 60. Therefore, an increase of 60 grade 11 learners are expected per year. The second problem is that the population within the first 5 years did not grow as predicted, and it was found that a better prediction model is f of x is equal to 1,200 plus 120x minus 24x squared. In this situation, we are going to answer 3 questions. And for the first question, what is the expected population for the school year 2021 to 2022? In your graphing calculator, we will press 5. Since the variable x represents the number of school years from 2016 to 2022. Then, press the stop button followed by the x button to assign 5 as our value for x. After that, input our function 1,200 plus 120x minus 24x squared. And this gives us 1,200. For the second question, what will be the rate of change of the population per year for the first 5 years? To answer this, we will press the Math button, then press the 8 button, then you will be redirected to the n-derived template again. Then just do the same thing as what you did on the first problem. However, our x value will be substituted with the numbers 1 to 5 to represent each year for the first 5 school years. After that, you will get the answers 72, 24, negative 24, negative 72, and negative 120 respectively. For the last question is that, what is the trend of the population of grade 11 learners of Silver National High School? To get the answer of this is that we need to press first the y is equal to editor button, then enter your function. After that is to use the arrow keys to place your cursor in an open equation in the y is equal to editor. Next to that is to press the Math button, then 8 button to have access again on the n-derived template. Put again on the d over d our variable x. Then inside the parentheses, press the alpha button and the trace button consecutively. In here, we'll just choose the y sub 1 as it is the variable which represents our function. And then press the graph button to do its graphing magic. So, as you can see from the graph, it shows 2 parallel like lines. However, in reality, it really shows a downward parabola that has extreme values that exceeds the graphing calculator's limitation to graph on screen. But no worries! We can see the actual values using the table of values. Press the second button followed by the graph button. So now from there, we can see the x values, which represents the number of school years for the first 5 years. The y sub 1, which represents the population of grade 11 students. And lastly, the y sub 2, which represents the rate of change each year. And since we have 1,344 as our greatest value, then we can conclude that the maximum or the trend of the population is 1,344. And that's a wrap! So from the discussion that we have tackled, we can say that in mathematics, graphing calculator is a great tool that can help us predict things. Once again, I am Anthony James M. Mecca, and you're watching Mathinig at Matuto.